This lesson is on section 5.2, bisectors in triangles. By definition, we talk about what a perpendicular bisector is. Remember that bisect means to cut in half. So a perpendicular bisector would be a line, segment, or ray that intersects a segment at a right angle and cuts the segment in half. So this gives you a picture of what a perpendicular bisector looks like. It comes through a segment and it comes through at 90 degrees and it cuts that segment in half. So the distance from A to B will have to be the exact same as the distance from B to C. There's a theorem that goes along with the perpendicular bisector, and the theorem states that if a point is on the perpendicular bisector, then it is the same distance from the two endpoints. In other words, every point that's on this line, we could call it, I suppose, line L. Maybe not. Maybe we don't want to call it line L. Okay. Every point on line L is the same distance to A as it is from C. Now we know that B would be the midpoint, because if it's on the bisector, that's the very middle point that cuts the segment into two equal pieces. But it's not just B, it's every point on here is the same distance from A as it is from C. So this green line shows that if I looked at this point in particular, this distance would have to be the same as this distance. We move on now to angle bisectors. Angle bisectors work a lot the same way. They still bisect, so it still cuts the angle into two equal parts. So this is a picture that shows this ray here bisects the angle, which means this part of the angle is equal to this part of the angle. Okay, and we have an angle bisector theorem that says if your point is on the angle bisector, so it's on this line that cuts that angle into two equal parts, then it is also the same distance from the sides of the angle. Now there's a little bit of a trick to this. You can't just draw the line out anywhere that you want. The line has to be perpendicular. That's how you show that it's going to the same place out on the angle. You wouldn't say that the distance from here to here would be the same as the distance from here to out here. Okay? So it has to be when you draw the perpendicular line out to the side that those distances are the same. So these green lines show exactly that when I drew the line from a point out to the side at a 90-degree angle, then the distances were the same because it's on the angle bisector. And that holds true for every point on that ray. Let's look at some example problems or how that might show itself to us. The first one is, if I give you this, can you see that this line is the perpendicular bisector? Your clues are that it makes a 90-degree angle and that you can see that this part of the segment is equal to this part of the segment, which means that it goes through the midpoint. So this line is the perpendicular bisector of this segment. So every point on this line is the same distance from this endpoint as it is from this endpoint. So that means that the distance here, which is 20, would have to be the same as the distance here, which is 3x minus 4. So if we set those two things equal to each other, then we can solve for x. If we added 4 and got 3x equals 24, and then divided by 3, we would know that x has to be equal to 8. We can do the same thing over here. This point here would have to be the same distance from each of the endpoints because it is also on the perpendicular bisector. So we would know that 2y plus 2 equals 18. And then we would work our algebra skills, minus 2 and get 16, and divide by 2 and get 8. So y would be 8. So in this case, x and y happen to both be 8. Okay, so that's one way that you can use the perpendicular bisector theorem to help you find some values, or to help you find some missing lengths. Another way is, if you'll notice, this avenue connects the Lincoln Memorial with the state capitol. And if I want to describe all the points that are the same distance from the Lincoln Memorial and the Capitol, I would simply have to find the perpendicular bisector of this road. So I'm going to go right in the middle of the road, which would be right about here. And then whatever road this is, because there's roads all over there, whatever road this is, every point on that road would be the same distance from the Lincoln Memorial as it is from the Capitol. Not just this point would also be the same distance from both, but every point on the perpendicular bisector would be the same distance from both places. Okay? All right, the third example, back to finding values of variables, back to algebra. Now this one, if you look here, this is an angle, and the green line shows a segment that is cutting that angle in half. These two arrows are supposed to show you that this angle is equal to this angle. So that means that this green line is the angle bisector. So these two angles are equal to each other, so we know that 6y would have to be equal to 4y plus 18. But then we also know, since this point is, or this line is being drawn at 90 degrees to the angle, to the side of the angle, that this segment is going to have to be equal to this segment, because this point is on the angle bisector. So the distance perpendicular to the side of the angle would be the same as the distance out this way to the perpendicular side of the angle. So we would also know that 16 has to equal 4x. And then we would solve using our algebra, so we'd minus our 4y and get 2y equals 18. And then we would divide by 2, and y would have a value of 9. And then we would divide by 4 here, and x would have to have a value of 4. Okay. That is the end of this lesson. It explains perpendicular bisectors and angle bisectors. Your homework for each section is as follows.